So here's the problem. Let's say that we're told that we have to solve a triangle in which we're given this information, two sides and a non-included angle between the sides. For example, in this illustration right here, I'm highlighting, I'm given angle A, I'm given side A and side B. I have enough information to use the law of sines, and this is the way that I would start out right here. So let's run through the situation and show how I might find my answer. So here we go. We have side A equaling 15. So we're told that this is 15. We could include whatever units we wanted to, but we'll get into units in a little bit. Remember, if you are given units, include the units in your answer. Let side B equal 8. So we know the length of this side is 8 right here. And we're told that angle A is 72 degrees. And so we're asked to solve the triangle. That is, find all the missing sides in angle. So we want to find side C, angle B, and angle C. How do we do that? Well, the very first place to start is that we have in our law of sines enough information to find angle B first. Why angle B first? Because we have its opposite side, we have an angle and its opposite side given, so we can set up our law of sines this way. We can start off by stating that if we want to find this angle B, we know that the sine of the angle B, whatever it is, divided by the length of its opposite side is going to be equal to the sine of the given angle A. So we'll take the sine of 72 degrees and divide it by the length of its opposite side, which is 15. All right, so if I'm going to solve for sine B, here's what I'm going to do. I will say that the sine of angle B, whatever it is, will be equal to 8 times the sine of 72 degrees, whatever that turns out to be, divided by 15. And so I'm going to have to work out what this number is, which means, yes, that's right, in this section we are going to start using some calculators. So this is a calculator problem. So I brought out my calculator. I'm going to work this out. Let's take the sine of 72 degrees. We're going to multiply that by 8, and then we're going to divide by 15, and we're going to get this big long decimal. I will tell you, I will warn you right now, if you're going to get this decimal, carry it out to at least 4 decimal places of accuracy so that you can get the correct number. So in this case, 0.5072. So we know that sine of angle B is equal to 0.5072. Right? So how do we find angle B? Well, this is a job for our inverse sine function. We're going to take the inverse sine of the quantity 0.5072, and we're going to work out what that angle will be. And when you get your angle, let's work this out to an accuracy of 100ths. Right, so we want hundredths here. So I'm going to take my inverse sine of this number right here, and I come out with if I round up, 30.48 degrees. So I'll write it as 30.48 degrees. Okay, so we always want to give that to the nearest degrees. Also, don't forget there's a degree mark here. Okay, so that's really important. It is important to give that to. So let's take a look. Okay, so we found angle B. Well, what can we do with that information? Well, the next thing that we can do is that we can find angle C. We can find angle C because angle C, we know because the internal angles of a triangle add up to 180 degrees. We're going to find angle C by subtracting the other two angle sizes from 180 degrees. So we will take 180 degrees and we're going to subtract 72 degrees and subtract 30.48 degrees. All right, let's see what we get right here in this particular case. If we work it out, We take 180, we subtract from that 72, and we subtract from that 30.48, and we get our result 77.52. So our answer right here will be 77.52 degrees. All right. So that's number 2. So that leaves us with side C as the last step, side C. So if I'm going to solve for side C, I'm going to use the other version of my law of sines. That is the one with the sides on the top. I know that the length of side C divided by the sine of angle C, which is 77.52 degrees, is equal to the length of, well, we could pick any of the two sides, but go with the given one. Always go with the given one right here. So we're going to go with side A, which is 15, divided by the sine of its opposite angle, so the sine of 72 degrees. So we're going to work this out for solving for side C. The reason that I use this form if I'm solving for a side is that, well, the calculation's actually really easy. We just take 15, we multiply it by the sine of 77.52, degrees, and we're going to divide that by the sine of our given angle of 72 degrees. All right, so working that out, I'll get out my calculator again. We're going to take the sine of this angle, we're going to multiply that result by 15, and we're going to divide by the sine of 72 degrees. That gives me 15 point, if I round up, 40, so let's make it 15.4 exactly. 15.4 is the length of side C. All right, I always take one more step, and that is I check. Now, how can I possibly check? Well, in this case, set up a table. You're going to set up a little table that has the length of your sides and the lengths of your angles. This is just a very simple little test. And in this test, what you're going to do is you're going to put the length of each side opposite its angle. So we know that we were given the length of side A is 15, and its opposite angle was 72 degrees. We were given side B was 8, and we found that angle B was 30.48 degrees. And then we found the length of side C was 15.4, and that the angle C was 77.52 degrees. Now, the reason why this is important to do is that you'll note the following. We note that the length of the largest side must be opposite the length of the longest angle, right? So we have 15.4, the largest side opposite 77.52 degrees, the largest angle. And the smallest side must be opposite the smallest angle. So side B, which is 8, and angle B, which is 30.48 degrees, is the shortest. So it makes sense. Our check here is just to ensure that our arrangement is correct. And if we do that in the right way, we'll always come up with the correct answer. Okay, more examples to come.